I love hearing Mr. I don't know if he does this, anyone's not the head coach. I love hearing Mr. Hatfield like go to try to argue something with the ref because he's so calm.
Yeah.
Like explain this to me. Like and he'll be like, it's like really intense and he's just so calm and he's like
focused on what he's trying to ask.
Yeah, and he's so, he's just he's good at arguing, and because he's smart. I mean, but I love, sitting at the table, I can hear the whole thing. And I'm just
because he knows what he's talking about.
Right. But he just knows how to convey his argument well. I don't know. He's just good. Because I'd be up there and all emotional. No! I'm
I don't know how to stay so calm. I'd be so calm.
I like when Max and Ben ask her to coach me because literally if they disagree with the ref will just be like, okay.
Yeah, whatever you say, guys.
Because they're famous.
When the boys were little, they went to I don't know if I told you that story. They went to little wrestler camps with Max. Oh. Yeah, when he was in we went down to because we lived in Grafton, so we went to the Mecklenburg Thiensville or whatever, and because I just loved it, and they were just just to work out with them was so cool, they were awesome, and I'd be kind of when you talk to me and he's intense and dude. All right, which ones do we need to go over? We need to go over one. Okay. All right.
Just go over all.
Oh, back up.
Sorry.
It's okay. I just forget.
Save rules. Our kids and taking videos of him, and then he was just there's a kid that did that, and then he just pushed him over, and then
All right. So this is the one where we have to put in the x values we know. So I'm going to do f of 0 plus h minus f of x, but I know f of x equals 5. Oops, why that happened. And then, so this has to get substituted into our equation. So I'm going to just write that over here. 0 plus h is just going to be 0, bless you. Or sorry, it's just going to be h. So, I guess this one's not very complicated. So this is what's going to go in place of that. So you're substituting 0 plus h in. Well, 0 plus h is just h. So I'm substituting that in place of the function. So 2h squared minus h plus 5. And then don't forget that minus 5 that was already up there, all over h. So these cancel. I can divide an h out of these. So I'm left with 2h minus 1. And then again, we're going as h approaches 0. So that makes this cancel out. So it just ends up being a negative 1. Other questions? Nope. All right, so let me show you. So one more time, we're going to do the problems the long way. Guess what? Take out because I didn't write this part, but don't forget that the question was, why did I take out the 2h? Remember, we're doing the limit as h approaches 0. So as this gets closer and closer to 0, that's going to just be non-existent. So 2 times a number really, really close to 0 is just going to go away. So it's when we say the limit approaches, the h is approaching 0, we're basically saying it's going to equal 0. Technically it never does, but it gets so close that it's so small that 2 times a very, very, very small number ends up being not even worth mentioning. So we're going to do the long way one more time. When we do this today, we're going to do the one more time so you guys can see the pattern for our short way. So I'm hoping today goes better. So.
Yeah, I remember at the was the national fundraise. Team Wisconsin almost got on Team Georgia. At Culver's, yeah.
At Culver's?
Yeah, because so we were walking past them, and then I went to this one of them, just
nice.
yeah. And then he goes, nah, F you. And then like all of my teams were like, what are you saying? Like we were like exchanging back and forth. I thought we were about the problem. But then what stopped it was I knew a kid that was like standing in the back from like literally like years ago, like when we were kids. I was like, yo, what's up? And then everyone was like, what? Because everyone was arguing.
Yeah.
And then me and that kid started talking. And then like, we were good. I thought we were good.
That would be so funny if probably.
Was this after or before you?
This was like in the middle. Because there was 2 days.
So you guys never
So like after the first one.
No, they suck.
Oh.
Like they suck. So
Maybe
were
they knew
like-
you guys were good, so they're like,
They were in like the really bad pool.
Were you guys in the good pool?
We were in the silver pool, but we should have done in the red.
Did you business in your pool?
Oh wait, no, we were in the gold pool. We were at like, yeah, we were in the gold pool.
the bottom of the
What place did you
pool.
guys stay?
We took like 7 in the gold pool.
Did you win?
Huh?
Did you win the matches?
I went like 2 and 6. No, it wasn't 2. It was like 2 and 4.
You know, it's 6 times.
Well, it was 2 days.
Oh.
No, I think it was 3 and 4.
Actually.
Huh? It was in Indiana.
I feel like that's a good advantage for me.
Well, they suck too. My dad from Indiana.
This almost started a fight.
I put him on my shoulder.
Of course, it was Stone that started it.
And then threw him backwards for 5 and back him. And then he was all
That's
that.
the true style.
Yeah, and then that was the guy that called Ben Jake Thomas.
You still made on the
Um,
fight?
yeah.
Let's go.
We had like 5 gingers on our team. So then our coach
Did
was
you guys just
like,
get bullied?
no, our coach was like, we have to send out the ginger vortex for the Pokemon. Because he said that like gingers like make vortexes when they're like, when you have more than 3 of them together at a time. They like open a black hole. Our coach, like the Team Wisconsin coach. So then he sent him out. He's like, we won the duel. We already won the duel.
But,
And our champ, no, we won that duel.
oh.
It was against Florida. Florida kind of stinks.
Alright, who stinks besides you guys?
Yeah.
Pennsylvania, Illinois,
They're all
Minnesota, Ohio.
But who's better than you?
How do you even get all of them? You just get picked or
He
what?
wins.
No, name names so you can further demoralize yourself.
What do you mean?
Name all the groups better than you.
Okay, we'll focus here. All right, enough story time.
Each person.
It was a pretty good story.
It was.
Stone has good stuff also. It's always interesting. I wanna.
Becca's gonna give a story
Oh,
time.
am I actually?
I don't know.
Videotape.
We would listen to you.
Well, I don't have my key card, so maybe we can. It's my lock.
All right. So we're gonna talk about how to find the derivative today, like the long way, and then I'm gonna show you guys the shortcut for the short way. So with this, now this one's asking for any point, and then we'll deal with the specific points down in the bottom. So what that means is I'm gonna use this formula, but I'm gonna use x plus h in my formula. So when I go to do this, so this will take a little bit of space, so kind of maybe write small to begin with, maybe spread out and use as much of this as you can. So what I'm gonna do just off to the side is I'm gonna put x plus h into here so that I can like put that on the top without having to have the whole fraction going. So x plus h is gonna go into my equation here. So I'm doing just like this part right now. Now the issue is that x plus h squared is one we have to FOIL. So I have to multiply it by itself. So I'm doing x plus h times x plus h. h squared 5x 5h plus 6. So I think that's that foiled, I believe, unless someone sees something wrong with that. So that's going to go up into this equation over here. I should have left myself even more room. Because I still need to subtract off the f of x. So I have to do minus the function itself. So minus x squared plus 5x plus 6. So I have to subtract that function off. But the good news is here, a whole bunch gets to cancel then, because I'm subtracting off like part of this equation. So if you look here, x squared minus x squared will cancel because it's being subtracted. 5x minus 5x will cancel. 6 and 6 will cancel. So I'll be left with oh, not over 5, over h. So all that, like, so we can divide an h out of all these, right? So all of them can be divided by h. So I'm left with 2x plus h plus 5. Well, each of those will cancel one of the h's, right? And remember, with like going back to Sam's question, we're doing this as the limit when h approaches 0. So it's kind of like this h is just going to vanish. So I'm going to be left with 2x plus 5 is my derivative. So once I know that derivative and they give me some values for my x, I can just substitute those values in. So finding the derivative and then finding out different values at part of that, like, so like again, we use these a lot with problems like real world problems where we're throwing something, we're driving something, something's going fast and we need to figure out the speed at a certain time. And so if I want to know what's happening, you know, when time is 0, when time is 2, when time is 4, I want to be able to substitute that back in a bunch of times. So then all I have to do is put these back in. So -2, or 2 times -2. And I still haven't shown you the short part yet. So this ends up being 5. Wait, no, that doesn't. I was thinking of, in my head, I was doing the second one for us. So excited things were going so well. That's what I get for being cocky here. So -4 plus 5 is 1. Sorry.
So it has to humble you out a little bit.
Yeah, right, yeah, because I can't like just have like a day.
Yeah. No, never.
All right. Okay. So, what I want you guys to see is how I can bypass all this work and take this and go to that. So, there's a direct connection between this compared to that. And it doesn't really look exactly like it, but maybe you can see it. So, look at the first term. I go from x squared to 2x. And then the next one, I go from 5x to 5. So what essentially is happening here is, and I'll explain it a little bit better, is this power is dropping down in front. So the squared is going to become a 2x. Then we just get rid of that x off the 5 because technically it's like a power of 1. It's being multiplied to the 5. So what's going to happen is we're going to be able to go from the green to the final green without having to do all of that work. And again, like that's why I was totally like, what happened here is because I didn't know why we were doing all that, to be honest. So let's flip the page. I'll show you guys how to do this quickly. Not that one. All right, so the power rule for derivatives. So again, this is our shortcut. This is the way to bypass all that crazy work. And it's a little bit hard to explain in words. I'll try my best here in terms of like writing it on words. It's like a paragraph in our book. But you're taking this power and you're going to drop it down and multiply it to the coefficient. So the power gets multiplied to the coefficient. So if there's not a coefficient, you just drop it in front. It doesn't like my C's. And then we're going to take the power down by 1. And maybe it'd be good just to talk about this as an example here right away. So this 3 is going to go into the front and multiply to that coefficient. So 5 times 3 would be 15. And then the power is going to decrease by 1. So I'll write this as best I can. So it's going to be a times n times x. And then it's going to be like the n minus 1 power. So like as a variable, it's kind of icky there. Now if it's just a constant, there's no x to deal with. That term just completely goes away. So if you noticed in our problem on the other side, that 6 just vanished. So that 6 is just going to cancel every single time, or that constant's going to go away. So that's just 0. So f. So it's just nothing if it's a constant. So this 4 doesn't need to be in this problem anymore. So the derivative of this, using this power rule, is just 5x to the second. Yeah. Now again, we could do this the long way, and then you could like want to walk out, because you'd have to do x to the third, and you have to write it 3 times rather than just foiling, and so it's horrible. It's just not fun at all. So try example 2 here. See if you guys can figure out what the derivative would be. So our h prime of x here. Example 3 is a little bit tricky. I'll talk about that one in a second. So what's our derivative here? Yeah, 2x minus 4. So the minus 4 comes from, this technically has like a first power. So it drops down in front, multiplies, it doesn't really change it, but then the x becomes an x to the 0, so that just cancels. So it's just 2x minus 4. Now, we won't deal with many like this down here. But it's 2 things being multiplied together. So what we're going to do is just multiply it together first and simplify it that way. And then we should be able to do our derivative that way. So add your exponents right now, multiply the coefficients. and then so we'll do our derivative. So this would drop in front. That goes down by 1. This one drops in front, goes down by 1. And then this one drops in front, goes down by 1, so we just end up with a 6. And then if there was like a number on the end, like a +5, like in that one or something like that, we just, like that one just goes away because there is nothing to drop in front, essentially. It's like 0 times that number. All right, so the good news is for this is once we know this, if they ask us like what is time at, you know, when time is 5, what's the value going to equal, we're able just to substitute that into the derivative right away. So there's not a ton of work to get there. Yeah.
So this replaces like all of this?
Yeah.
Oh.
Yeah. Now all of that, like I said, I was talking to Mr. Hatfield, he always asked that his students did it like one time on a test. So like doing basically like the first part of what we just did, like show me once you guys know how to do it the long way. Clearly that didn't stick in my brain when I was ever learning this, that like I needed to know how to do it the long way very long, because I always remembered just this. I mean, obviously it's the easy way. So, yeah. So hopefully from now on we can just use that other than when we have to show it once on a test. So, do we want, Becca was gonna talk first, but she says she's not going to anymore.